Hey there and welcome. Every single day, millions of us step into an elevator without giving it a second thought. But have you ever stopped to wonder about the incredible invisible system that makes it one of the safest ways to travel on the entire planet? Well, today we're going to pull back the curtain and explore the genius behind all that safety.
So let's just jump right in with a question. Think about it. We trust these machines with our lives, right? Flying up hundreds of feet in just a few seconds. So what is it, really, that makes an elevator statistically safer than even walking down the stairs? What's the secret?
Well, the answer is actually incredibly elegant and super robust. It's a concept called the safety chain. Now, it's not a physical chain made of metal or anything like that. It's an electrical one. Just try to picture it as this single, unbroken loop of constant vigilance that is the absolute heart and soul of elevator safety.
All right, so to really understand this chain, we've got to start with its fundamental principle. This is the core logic that basically everything else is built on. This right here is the magic, the safety series circuit. It's a simple but totally brilliant all-or-nothing system. You know those old-school Christmas lights where if one bulb burns out, the whole string just goes dead? That's exactly how this works. Every single safety switch in the elevator is connected in one long line. The default state for these switches is normally closed, which means current is always flowing through, telling the system, hey, all clear. The moment even one of those switches opens, if one bulb goes out, the entire circuit breaks, and the elevator comes to an immediate, safe stop.
So, where does this electrical safety chain even begin? Well, it starts with the parts we all interact with every single time we ride, the doors. They are the first, and you could argue, the most critical line of defense.
To keep an eye on the doors, the system has a whole team of switches. We're talking about landing door locks and the car door switch, among others. Each one has a very specific job, but they're all working together to answer one absolutely critical question. Is it 100% safe to move? First up, the landing door locks. And get this part is so cool. The elevator doesn't just check the door on your floor. Nope, it confirms that every single door in the entire shaft is mechanically locked shut. So if a door on the 20th floor is even slightly ajar, the elevator on the first floor isn't going anywhere.
Next up is the one we've all experienced, the car door switch. This makes sure the door of the cabin you're actually standing in is completely closed. You know that moment when someone tries to hold the door open and the elevator just refuses to go? That's this switch right here, doing its job, breaking that safety circuit until everything is secure. Okay, so the doors are locked and our safety chain is complete. We're on the move. But the system's job is far from over. In fact, now a whole new set of guardians takes over to watch the elevator's journey through the shaft.
These are basically the elevator's internal senses. They're constantly checking its speed, its position, even the tension on the ropes. Think of them as the silent sentinels watching over you as you travel up and down.
At the top of that list is the governor. You can think of it as the elevator's speed cop. If, for any reason, the car starts going faster than its maximum safe speed, the governor physically trips a switch that instantly breaks the safety chain and slams on the brakes. It's the #1 defense against going too fast. Then you've got the final limit switches. These are the absolute last resort, the break glass in case of emergency switches. If all the normal controls somehow fail and the elevator travels too far up or too far down, it's going to hit one of these. When it does, the safety circuit is broken and all power is cut. It's a perfect example of the layered, redundant safety built into the system.
Now, beyond all these automated checks, the safety chain also has manual overrides. But these aren't for passengers. They are designed specifically for the technicians who work on the elevators, giving them direct hands-on control. You'll find these big red stop buttons in all the key service areas, way down in the pit at the bottom of the shaft, right on top of the car itself, and inside the main control panel. They let a technician immediately stop the elevator before they start to do any work. Their job is simple but absolutely vital. Pushing one of these buttons does the exact same thing a faulty door lock or an overspeed governor would do. It manually breaks the safety circuit. This makes sure that the machine cannot move unexpectedly while someone is working on it. It's safety for the people who keep us safe. So, we've met the door guardians, the motion sentinels, and the manual controls. Now let's put it all together to see why every single link in this chain and the expertise behind it is so unbelievably critical.
Let's walk through a scenario. During normal operation, current is just flowing freely through that closed circuit. But let's say a single landing door doesn't lock correctly. Instantly, that switch opens. The chain breaks. The power to the motor and brakes is cut, and the elevator stops.
It's not a slow reaction, it's instantaneous. The entire system is designed to fail into a safe state.
And that really gets to the heart of it, doesn't it? The safety circuit isn't just a collection of parts. It's a complete, holistic system. And a system like this is only as strong as its weakest link, which is why the quality of every single component is absolutely non-negotiable.
So, the crucial takeaway is this. A system this complex relies entirely on two things: the quality of its parts and the expertise of the people who install and maintain it. There is just no room for error. It's not optional, it's everything.
And that principle of specialization is just so key. Expert teams like the ones at Novin Elevator, for example, build their entire reputation on this commitment. By focusing on the highest standards for every component and every installation, they ensure each link in that safety chain is robust, reliable, and ready to do its job at a moment's notice.
So the next time you step into an elevator, you'll know all about that silent, invisible chain of circuits that's working nonstop to guarantee your safe journey. It's really a testament to brilliant, fail-safe engineering. If you happen to be involved in building management or construction and need expert advice on these systems, you can find more information at novinpuyalift.com or reach out to the specialists at Novin Puya Elevator directly. Thanks for watching.